In this final section, we're going to discuss purification and treatment of water. There are many uses for water. Drinking water is the most basic use, as water is required for all life. Other uses include household use like cleaning, recreation, agriculture, industrial, and medical purposes. Depending on the way water is used, it must be treated for it to be safe for consumption. Collection and pre-treatment of water. Before water can be treated, it must be collected, screened, and stored. 1. Collecting the water. Water is pumped from a source, such as a river or lake, and stored in a holding tank. It is important that the means of collecting the water does not contaminate it. 2. Screening. Water is screened through filters to trap large objects. This is more important for water collected from lakes and rivers than water collected from groundwater. Water used to be chlorinated to kill any pathogens, but because chlorine has known health effects, this is no longer done. Collecting rainwater. Rainwater can be harvested for home use, but should be treated further to prevent illness. If the rainwater is not treated, it is generally safe to use for watering plants or cleaning objects that are not used for cleaning. In the picture on the right, rainwater is collected from a gutter and passed through a filter into a storage container. Treating water, adjusting the pH. The pH of pure water is 7, which is neutral. Seawater has a pH that ranges from 7.5 to 8.5, which is slightly basic. Note, although seawater can be desalinated, having the salt removed, it is too costly to treat seawater this way. Freshwater can be acidic or basic. Acidic freshwater with a pH of less than 6.5 may have been contaminated by industrial pollution and is often found near power plants, mining sites, and landfills. Freshwater that is more alkaline or basic with a pH between 7.1 and 9.5 is mainly from groundwater. It comes from water that passes over rocks and picks up minerals. Treating water, adjusting the pH. Drinkable fresh water has a pH between 6.5 and 9.5. Drinking water that is slightly alkaline is tolerable. It is often claimed that it can have health benefits, such as supplying electrolytes, but this is not proven. Water that is acidic is not safe for humans to drink. Although people can drink coffee and orange juice, both with a pH lower than 6.5, acidic water is most likely contaminated with harmful chemicals. To make acidic water more neutral, lime, soda ash, or sodium hydroxide can be added during the water treatment process. All of these substances are more basic, so that will make the water more neutral. To make alkaline water more neutral, coagulation and flocculation is used during water treatment. This process removes the minerals on suspended solids that make pH alkaline. Coagulation-Flocculation. Suspended solids, such as clay in alkaline water, may have similar charges. They will repel each other and not settle. Therefore, they will stay suspended. Coagulant chemicals with charges that are the opposite of these suspended solids are added into the alkaline water. Once the solids are neutralized, they can stick together. The water is then mixed vigorously. The small solids stick together and have coagulated. After coagulation, flocculation is used to further promote agglomeration, or a collection of coagulated solids, now known as floc. This is done with a gentle mixing. At the last stage of flocculation, the floc settles to the bottom, as you see in this final image here. Treating water sedimentation. After flocculation, the water enters a sedimentation basin. This sedimentation basin is a large container or pond that has slow-moving water so that the floc does not get disturbed. The water transfers to the basin gently to keep the floc at the bottom. The water will flow out of the sedimentation basin at a rate of less than 1 gallon a minute. There are a couple of different types of basins, but the simplest is a rectangular basin, as the one shown in the image. With this basin, cleaner water is pumped off at the top of the tank. So the water comes in here and goes out here at a rate slow enough to keep this solid waste sludge at the bottom. Treating water filtration. After sedimentation, the final step for treating water is filtration. This is necessary to remove any remaining particles that are still suspended or flock that did not settle and was not removed during sedimentation. There are two main types of filtration: rapid sand filters and slow sand filters. Both of these are used for more large-scale water treatments. Membrane filtration is often used for small-scale treatments. These are used after sand filtration and include microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. Rapid sand filtration. In rapid sand filtration, flocculated water is pulled through a sand and gravel mix by gravity, or it is pumped through. As the water flows through the sand and gravel, any leftover flock in the water is trapped in the sand and gravel matrix. Note: other media besides sand can be used, so rapid filtration may be a more modern term. Slow sand filtration. Slow sand filtration uses a complex biological film to filter flocculated water. This biological layer, referred to as Schmutzdecke, often contains bacteria, fungi, larvae, and other small organisms. These organisms break down contaminants in the water. Unlike rapid sand filtration that relies on pressure and sand to trap flock, slow sand filtration uses living things to break down the flock. Because water flows very slowly in slow sand filtration, sufficient space is needed to set up these filter systems to filter enough water for a large population to consume.